is go ahead and solve these two inequalities, please. Solve the inequalities. And if you don't remember, talk to your partner beside you. Maybe your partner remembers. If your partner doesn't remember and you don't remember, just kind of think about how you might want to solve this. Now, absolute values, what does that mean? What does absolute value mean?
There's two graphs. It's a piecewise function.
What does it mean? What does absolute value mean? Distance. It is distance. So absolute value means distance.
Oh, it says it right there.
So you're all doing the V shape, and that's cool that you all know the shape of the absolute value. I think that's awesome, actually. I think it's really cool that you all remember that. It is a V shape, but it is a distance. So we are looking for distances that when I add 3 to it, or subtract 3 to it, I get 7 as the distance. So A and B, I am chasing distance. I want to find an X value that makes these true statements. And everyone's like, oh, well, I'm going to get 2 answers. Yes, you're going to get 2 answers, and this is why. Just as a refresher, if I said, here is 0, here is 3, here is -3, how far is -3 from 0? 3 spaces. How far is 3 from 0? 3 spaces. So if I said to you the absolute value of x is equal to 3, then you would have said x could be -3 and x could equal +3. So if I then said I need the absolute value of x to be a distance less than 3, what do you think is going to change? I want any numbers whose distance is that has a distance of at a max 3, not inclusive of 3. So I know that if I had -3 here and 3 and x was sandwiched in between, that has to hold true. Do y'all remember that? Cool. Go ahead and do A and B then. All right, so using the same thing we just did, is I need distances to be less than 7. So when I take a number, subtract 3, I need its distance to be less than 7. So I set it up with -7 is less than x minus 3, which is less than 7. Do you all agree to that? Yep. Then I'm going to go ahead and add 3 in the middle and on the ends. So I get -4 is less than x, which is less than 10.
I like that. That's a good way to that way.
That's what I did in pre-calc 1. I'm sad that you don't remember that. I never break these things apart. All right, so using the same type of reasoning in the next one, I have -5 is less than or equal to x plus 2, which is less than or equal to 5. What am I going to do to every piece, middle, end, and other side? I'm going to subtract 2 from everything, so -2, -2, -2. So I end up with an answer of -7 is less than or equal to x, which is less than or equal to 3. In interval notation, that's how you would have done it back in pre-calc 1. So -7 to 3 with brackets, and then up here, parentheses, -4 to 10. Now the reason that we're spending the time to refresh our inequalities, there's a reason for it, is because when we start doing our epsilon delta proofs, we're going to need to know and remember that if I'm given the absolute value of x minus some number is less than delta, so that funky looking s thing is delta, that first of all, that absolute value is going to be at least 0, but we're going to focus on the ones that are bigger than 0. So when I have that, what I can do is I can break it apart from negative to positive delta and then add x or a everywhere. We will pick this up tomorrow. Is that you can bust them apart with a positive and negative, and that value in between the x plus 2 as an example could be sandwiched between the -5 and the +5. So when we go back to our epsilon and delta, and when I'm talking about delta, that's this symbol right here. So that delta is that symbol right there. That if I have the absolute value, first of all, it's greater than or equal to 0 because it is a distance. We're going to say it has to just be strictly greater than 0. So if it's greater than 0, the absolute value of x minus a is greater than 0 but less than delta, then that means I can break it apart just like I did up above. As I would have had delta on the negative delta on the left-hand side, I would have had x minus a in the middle and positive delta on the right-hand side, and then I would have added a to everything. Just like we did above, I subtracted 2 from everything. So we end up with this. Oh, that's not what I wanted to do. We end up with this. Okay? Now we've got to remember the delta goes with our x. So when we're talking about delta, we are talking about an x. We're talking about an interval in which x is between a negative delta and a delta, or an a minus delta and an a plus delta. It depends on if we have an a or not. If we say that our x has to be within an interval, then our output has to also be in an interval. So this part here is saying my outputs will be in an interval. Okay? Where f of x is the output, L is the limit value. So we're going to a limit value. And the difference between my output and my x and the limit should be a very small number, and we call that number epsilon. So that's what that is. That's epsilon. That is a very small number. And just like we did on our one up above with the delta, is we break apart our inequality and our absolute value, so that our absolute value and our inequality end up breaking apart and looking like this. Now let me repeat. L is the limit. So what I'm saying on this part is the output that I have when I put in some number and the limit value should be really, really close together. So if I take the distance between what I find is my output value and what my limit is, it should be almost nothing, and that's why we call it epsilon. So epsilon goes with my y's and my limits, and my delta goes with my x's. All right, does that make sense? Okay. Here's how we formally define this in all of its glory. Let me see if I can get it all in there. So this is how we formally define this, and I'm going to go ahead and stop the recording so you all have the chance to write that. Now, graphically, this is what it looks like. So I have my a value, which is right here. That's my a value. And notice on either side of my a value, I have taken my a and subtracted off delta. That gives me my left part of my interval. I take my a and add on my delta. That gives me my right part of my interval. So this interval in here is from a minus delta, comma, a plus delta. Although those kind of look like, I don't know what they look like, but those are deltas. So that's what that signifies. That a minus and a plus delta is this interval here, from here to here for my x values. So then my outputs, saying here's where f of x is, here's my true f of x, right here. There's my f of x. My limit will be in here with my limit plus my epsilon, and then my limit minus my epsilon. So my range in which my true limit is going to be in is going to be between L plus epsilon, that's my, L minus because that's the lower limit, comma, and then L plus epsilon. So those are the range in which my limit should be in, or my f of x should be in. How are we doing? Okay? All right. So then we keep moving. So I'm going to give you a moment to write down these translations, because these will help you with your epsilon delta proof. So go ahead and write down these translations. On these, all they're asking us to do is write the appropriate epsilon delta pieces. So if I go back to my example that I had before, so I'm going to do it over here. I had f of x was equal to, we'll do 5x plus 3. The limit as x approaches -1 of 5x plus 3 would give me, when I put a -1 in there, I'm going to, well, let's choose something else. Let's choose -2 because I don't want it to be the same exact number. So when I put -2 in there, then I can do a direct substitution. So -2 times 5, which is -10, plus 3, which gives me 7. To write the appropriate epsilon delta pieces for this particular example, I would have my x minus a -2, because this is the x minus a part. And it's going to be less than delta. Then I would have the 5x plus 3 minus 7 is less than epsilon, because this is the f of x minus L part. Does that make sense?
I think it's -7. You plug in
Oh yeah, thank you.
Yeah.
-7, so minus a -7. You got to watch me, I'm sketchy. Thank you for catching that. All right. How was that? Is there any questions? So going back over here, you're going to do the same kind of thing. It's just you don't have numbers. So it's just getting confident and prepared for the actual proofs. So go ahead and do A and B, finding the appropriate delta and the appropriate epsilon. First one.
For the first one, I put the absolute value of x minus a is less than the delta, and then I put the absolute value of f of x minus n is less than the epsilon.
Yes. Did anyone get anything different? Okay. Raise your hand if you'd be willing to give me your answer for B for the delta and epsilon. Max?
I got absolute value of t minus b is less than delta. And the absolute value of g of t minus n is less than epsilon.
Yes. Did anyone get anything different? Do you want to go over any of these? All right. Cool. So when we're doing this, and when we start doing numbers here in a minute, ideally, we have an interval about x that is symmetric. But what ends up happening is if we have an interval around x that's symmetric with my delta on one and my delta on the other, then what ends up happening is that I may not get what I need for my L. So I don't have the symmetry that I need around L. So when that happens, then what we do is we do the minimum of these two things. And all that notation says is I'm going to take the minimum of a minus the lower value for y, and then I'm going to do a plus the lower value of y. And when I'm talking about y, I'm talking about the inverse of it that produces the x that produces that value. So that's why you have this inverse notation. So that inverse notation says I have the y, I want to know what x produced that, and I'll take the minimum of those two, and that's how far my delta will actually truly be. So let me give you an example in which we have symmetry and we don't have to do any of those shenanigans. So if we look down on this one, and I'm trying to figure out an appropriate delta, that for this one I have symmetry, right? So if I go from here to here, I have symmetry in terms of my outputs. Do you see the symmetry there? That when I come over, when I go up here and I go down here, I have symmetry to it. But when I come back to this one, the following function, I have a limit that's given to me as 4. I want to find a delta that satisfies this statement. Now I have the epsilon part, that's 1. So I know it's 4, so here's where 4 is. And I need to have an epsilon that's 1, so that means I'm going to go up 1 and I'm going to go down 1. So in that region is the region I need to find my delta. If I come down to 2, because that's where my A is, and I know it's my A because of this and because of that. Those are the two places I know that that is my A value. That's the value I put on my x-axis. When I go to find this, notice how this one is super close to 2, and this one isn't as close to 2. So that interval right now is not symmetric. It's not symmetric. So my delta, if I make this, let's assume this is delta. Well, actually, let's work it out. Let's find the deltas. So if I have this function, I'll tell you what it is. My function is x squared. My function is x squared. I have an output of 5. What did I have to put in to get 5? So I would have done 5 is equal to x squared. What is x then? Square root of 5. What is the square root of 5 in your calculators? Give it to me into 2 decimal places.
It is 2.24.
2.24?
Yeah.
Okay. Coming back to here, this is 3. So that means for this one, I have, again, I'm going to use 3 is equal to x squared. So what is x equal to? What's the square root of 3? 1.73. What I want you to do now is we're trying to figure out delta. So I want to do the minimum here of my lower one, which is 2 minus 1.73, and then the 2.24 minus 2. Tell me which one is the lower number. When I do that subtraction, which one is the smaller number? So 2 minus 1.73, what do you all get?
0.27.
So what is it?
0.27.
0.27? And then I do 2.24 minus 2. My delta is going to be the minimum of these. Which one's the minimum of these? 0.24. So for this one, my delta is not going to just simply be, let's plug in 1 on either side, or let's plug in 2 on either side. It is the smaller of the two. So I come back over here, and I'm going to use my delta, which is the 0.24. So this region and this region has to be a distance of 0.24. So this left one will be 2.24. And this right one would have been 2 minus 0.24, which is 1.76. Is that right? So if you don't have symmetry, you take the smaller of the two deltas. That still guarantees that I'm going to be in that interval. Does that make sense? So that's what all of that notation up here is. It's just saying I'm going to take the smaller of the two values, and that's going to give me the correct delta. So numerically for this one, I actually had to work out which one the smaller one was. And the way I did that was I knew what my outputs were. I just need to figure out the x's that produced those outputs. And then I added or subtracted it from my 2, which was my A. How was that? I've got some looks like I still don't know what the hell you just said. Do you want to do another example? Okay. Let's do another one that's lopsided. So here's my function. We're going to use the cubed function. So f of x is equal to x cubed. And let's choose, let me see, let's choose 8. So that'll be my L value. So my L value is 8. So the limit as x approaches 2 of f of x is going to equal 8. And I'm going to tell you that I want my function minus 8 to be less than 1. So that means that I'm going to go up to 9, and I'm going to go down to 7. Now what? Find the values of x that produce those outputs of 9 and 7. So that's what you're going to do now, is find the values of x that produces 9 and 7. So I know my x is 2. So what I'm trying to do now is I do x minus 2 is less than some delta, and I'm trying to figure out what that delta could be. So I did the 9 is equal to x cubed. When 9 equals x cubed, what do you all get? 2.08. When you did 7 is equal to x cubed, what did you all get? 1.11? Okay. So now I'm going to subtract 2 from the upper one, so 2.08 minus 2. And then from the lower one, I'm going to subtract it from 2. Which one of these is the smaller number? .08. You all agree that 0.08? So the appropriate delta for this is 0.08, because it's the smaller of those two values. Does that make sense?
Where'd you get epsilon?
I'm making it up.
Oh,
I just want to do it as an
choosing
example. Yeah, I'm going to choose an arbitrary one so it would work out. Yes?
So for y value, so we just pick a number, one above and one below, and then we find the delta value for those.
So in this case, yeah, if on the homework and on these, you are given the epsilon, and then you're trying to find the delta that's appropriate for it, and then you prove it's true. So it's a really circular form. It's a really circular proof. If it doesn't wrap itself up, you did something wrong. So it really should be, I picked this, oh look, it works out what I picked. In this case, I picked a 2 or a 1 so that it made it easy to find our deltas, because I just went up 1 and down 1 for my y's. I could have chose 3, I could have chose 7, I could have chose any number. I just chose 1. Okay, how was that? All right. For this example, there is no issue with symmetry when I choose my L value. So for these, I have the limit as x approaches 3 of f of x equals -1. The first one, my epsilon, I chose to be 2. So I'm trying to find an appropriate delta that's going to work for if my epsilon is 2. The second one, I chose an arbitrary 1. So I need to find the delta that works for that arbitrary 1. So we're going to do the same thing. Is we're going to go to 3. So when x is 3, here's where we are. And for 2, if I have a distance of 2 from here, this is my y value, there's my L, -1. A distance of 2. So from there, I'm going to go up 2. So where do I go from there? I'm going to go up 2. What is that number going to go to? So it's going to go to 1. And then I'm going to go down 2. Where's that going to go to? The x that produced 1 is right here. The x that produced the -3 is right here. So what would be an appropriate delta for this one? How far am I in from the 3? How far did I travel to either side? 2. So for this one, my appropriate delta would be 2. How was that? If you're like, I still don't know what the heck is going on, then you just say, I don't know what the heck is going on.
What's going on?
Okay. So let me clear up some of this and we'll do it again. All right. So they're telling me that my limit is -1 when I approach 3. So here is 3. My limit is -1. There's my limit, -1, which happens to be the output. I don't have a hole there or anything, so it just happens to be the output. From there, they're telling me I'm going to choose an epsilon that is 2, a distance of 2 from my output, or my limit, which is -1. So from -1, I'm going to go up to, which gives me here. I'm going to go down to, which is here. Now I'm trying to determine the interval in which I'm guaranteed to be in there for those outputs. So from that line that is drawn, I drop straight down to find the x, and I go straight up to find the x that produces those outputs. In this interval is where my x should be to give me an output or a limit of -1. How far did I travel from where I have my x? Here's my x, it's 3. How far did I travel to the left or the right on this one? 2. So my delta would be 2. How was that? So try it for 1. Let me erase all the stuff I put on there, and then try it for 1.
So much easier graphically.
Well, that's why I start graphically. All right, so again, my limit is -1. So here's -1. I'm approaching 3. On this instance, they're telling me my epsilon happens to be 1. So from -1, I'm going to go up 1, and I'm going to go down 1. Now I'm chasing my x values. So I go down, and I'm actually there. How far did I travel from my x equaling 3 to my left and right side? 1. And in this case, then, delta would be 1. My previous example, I did not have symmetry, so I actually had to figure out which delta to use. So if I have symmetry, I can just do this because I know it's a distance that's the same on both sides. These examples did not have symmetry on my outputs.
Oh, this makes sense.
So I had to find those values. Yeah, it's not a hard thing to grasp if you have somebody that can explain it to you, but reading it, okay. So these are the steps in which we are going to take to do the actual proof. First thing we typically do, actually, is we find a delta that works. It's not on there, but it should be there. The first thing we're going to do is find a delta that works. So we want to call this like the beginning here. Let's put the beginning here. Find a delta that works. So that's like pre to the steps. Find a delta that works. And you do it by picking an epsilon. And then you just follow these steps. Now don't write all these steps down because this is what you want to write down. Do you see those blanks? That's what you want to use. So don't write any of the rest of the crap down. Write down those blanks because that's all you have to do is fill in those blanks. That's it. After you find the appropriate delta. So don't give me the evils, man. Don't give me the evils. So write down those steps. So if I am given this limit as x approaches 2 of 5x plus 8 is equal to 18, then the first thing I have to do is figure out an appropriate epsilon. The way I figure out an appropriate epsilon is I use f of x minus L. So I'm going to use f of x minus L. And then my goal is to make this right here, this part, look like the x minus a part. Once I do that, I have the appropriate epsilon. So all I'm going to do is rewrite it, taking off the parentheses there. And when I rewrite it, taking off the parentheses, I have 5x plus 8 minus 18. That simplifies into the 5x minus 10. I can factor out of the absolute values a positive number without having to worry about losing anything. So between 5 and 10, I have a 5 that's common, so I'm going to factor out a positive 5. Once I've factored out a positive 5, I divide both sides by 5, and look, there is my x minus a. I have found my x minus a. That means this is the appropriate delta value. Because the way that we do this is it is x minus a is less than delta. So this is the appropriate delta. You always take your function right here. So you always take your function subtract off your L, and you do algebra so that it becomes an x minus a type look. Now remember on here, I had x minus 2 would have been my x minus a. With the algebra, there's my delta. Here is the formal proof. It's not very long. After I figured out the appropriate delta, I let epsilon be greater than 0. So here's the actual formal proof. The step above just helped me get to an appropriate delta. All of them will say choose delta. The delta that we choose is what we found from up here. That's the delta that we choose. This is in every single step too. Assume 0 is less than absolute value of x minus 2, which is less than delta. That's in every single proof. What's also in every single proof is busting that baby apart. The only thing that changes in every single proof is this a value and whatever we chose for delta. Look, this is where we started trying to find the appropriate delta. My appropriate delta is where we started. That simplified into this. But this part right here is just the x minus a. So if I take and multiply 5 times the absolute value of x minus a, I must be able to take the delta and also multiply it by 5, which is this part right here.
Can you explain that again, please?
Okay? So I have this rule that says if I have the absolute value of x minus a is less than delta, then I can multiply this side by 5 and I can multiply this side by 5. As long as it's a positive number, I'm allowed to do that. So this is basically doing that. But I said that delta is epsilon over 5, done. Circular. If you don't circle back where you started, you did something wrong. Literally, that's it. That's the epsilon delta proof.
So you're just showing your steps in reverse is all you do?
Yeah. Pretty much. And there you go, we've proved it.